Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody, and tonight I'm going to be talking about hurricane and weather and climate manipulation, how this is done and the specific technical mechanisms for doing this. Okay, so that's one topic. The main science topic, I'll be talking about Albert Einstein and quite a few of his discoveries. Now, last week I talked about Nikola Tesla, and it led into a number of topics related to atmospheric electricity. What was Tesla doing with atmospheric electricity? So that's one aspect of this, and of weather control. Let's just put it that way, because our weather, unbeknownst to most meteorologists, is controlled by electrical currents that come from the ionosphere. And where do those come from? They're part of the overall solar electric field, which is generated by the sun. All of this comes from the sun. But the idea that somehow the sun shines light, that's what we're typically used to thinking, that the sun is this fusion engine and it shines light. No, the biggest energy component of the sun is electrical. And that's what drives our weather. If the sun did not do that, we would not have clouds, we would not have rain, we literally would have very bland weather. There would not be hurricanes or tornadoes or cyclones or waterspouts or thunder or lightning. None of this would happen without the sun's electric field. And this is part of my discovery work that goes back, of course, 50 years now. But the issue is that the weather man, the NOAA people, National Oceanic and Atmospheric Administration, and the hurricane little agencies like, for example, the Hurricane Prediction Center, that uses all kinds of bizarre factors talking about hurricanes, etc. But that's all basically misinformation. So I'll be talking about specifically what causes the weather, and then we'll get down to once you know how the weather is actually formulated naturally, then you can do things to actually modify that. And I call these trigger mechanisms because you don't actually enter the energy in the weather systems. You use trigger mechanisms, and this is many times done in physics, where you can, let's just take a forest fire. For example, you start with a little match on a hot, dry day, and you take that match and you start the process, and then the heat of combustion continues the fire, and it grows and grows until it burns everything down. But it starts with just this little teeny match, or a little cinder, or somebody throwing a cigarette. And so that's a good example of nature's, the energy that's stored in nature that can be released with what I call a trigger mechanism. And so there's all kinds of other examples. The trigger on a cannon or a gun or other thing, or for example, nuclear reactions are triggered, where you set up a beam of neutrons into a nuclear cell, And that kicks it off. You need other conditions at the same time, but that's another example of a trigger mechanism. So once you understand these trigger mechanisms, then you can actually use those because the energy is just waiting there to be used in the ionosphere. But as I discussed last week, there's this dielectric material we call our atmosphere. And let me just go into a little more detail on the dielectric itself and how it works. The molecules in the air are little dipoles. And what does a dipole mean? That means it's a charge that's slightly separated, and those can be induced to be larger if they're put into an electric field, which they are. But because the atmosphere is warm and not in a frozen state, once you freeze the material like water, then the dipoles are frozen in, locked into a position. But if they're random to begin with, then you don't have any net electric field. But in the atmosphere, because it's air, the molecules are moving around, the little dipoles are moving in all different directions, and so the net end result is that they create a dielectric material which increases the atmosphere's ability to maintain a charge. It's a capacitor. It's like a battery. We live in this battery, and if you go outside, or if you say climb up a mountain, this is why the Sherpas, if you go to like Peru, or if you go to other places in the world, like in the Hindu Kush, the people go up in the mountains and stand on the ground with their bare feet. And that is to allow them to connect into the electric field, which is, of course, they're grounded on the feet side, and then their head has a very much higher, they're very much closer to the ionosphere. So it's a way of gaining energy. And so there's all kinds of things that the human body is basically an antenna. The nervous system in your body is an antenna, and that's why a lot of people have problems with like 5G and Wi-Fi and all of that, because you are an antenna. And interestingly enough, I'll just divert a little bit on that topic. When you meet people, they have a frequency, and the people who study auras, for example, understand this, that every person has an aura that is different and is very characteristic to their personality, etc. But if you're not quite tuned to that, even though you're not aware of it possibly, when you meet people for the first time, you talk to them, all of a sudden your spiritual energy, you might call it, to lack a better name, because in science, if you can't put a meter on it and measure it, then according to standard science, it doesn't exist. But let me use a specific example, and hopefully many of you have had this experience in your life. As you're going about your daily business, you're walking someplace, you come around the corner, and like this, all of a sudden you're confronted with a person, and this is say men and women meet, and all of a sudden there's this like they call it chemistry, or it's like a magnetic field, and the two people just, for some reason, they connect right away. Their mental connection occurs, and this is very real, because you physically are an antenna, and you're transmitting and receiving signals from other people. And this is downplayed in Western society. There are other societies around the world that actually make use of this, and for other things, like for prayer. If you gather 2, 3, 4, 5, or 10, or 100 people outside, not in a church, but outside, you and pray, you can put your energies together, and they are much more powerful than one person or 1 or 2 people by themselves, especially one person by themselves. And so anyway, getting back to the idea of the vertical electric field, weather systems are driven by the vertical electric field of Earth. And as I said, this is a subcomponent of the solar electric field, which is emanating constantly from the sun in the form of what we call solar wind. But standard science again is wrong about this. The solar wind has an excess current of protons. Now it's not necessarily an excess of protons, it's an excess current, and that's a very subtle statement. You have to understand physics to understand what that really means. But the majority of charge coming off the sun and Jupiter and Saturn also do this because they are small unlit stars, unlit in the visible spectrum. But anyway, then within the realm of Jupiter and Saturn, they have all kinds of electrical effects. You get the spokes in Saturn's rings. You get the rings themselves, which are spiraling inwards. And you get a whole plethora of other effects. The same with Jupiter. You get the discharge between Io, the closest moon of Jupiter, and Jupiter, the planet. I've shown this before in my show. So they have their local electric field, but also they're coupled to the solar electric field. And this picture behind me, right here, shows a solar nebula in which the material is swept out of the solar system. That's a nearby star. That's a picture of a nearby star. And you can see the cloud of dust and gas that's being held back, and that's where a lot of planets are forming. That's what in our solar system we would call the Kuiper Belt. That's why there are thousands of planets forming out there, because it's very rich material, a quantity of material in the form of plasma, and it's also within that solar capacitor. So, okay. But all of the planets, let me simplify this, all of the planets, including Earth, where we live, is discharging this solar capacitor. Earth by itself does not have any ability to form an electric field. So, I mean, if you're a physicist and you're listening to this, and we know that there's a vertical electric field, 300 volts per meter, Tesla knew about this. He was using it. He was extracting energy from the vertical electric field and distributing it underground, through the ground. And he knew the resonant frequency of ground, so he knew the frequency at which to transmit his AC signals and light up light bulbs around the desert, around his Colorado Spring facility, or the same situation with the Wardenclyffe Tower. I talked about that last week. But where does this voltage come from? It doesn't just self-exist. It's not part of a magnetic field. It's an electric field. And so there's a huge misnomer in standard astrophysics and astronomy that somehow magnetic fields just exist out there. Oh, they just exist. They're just there. You can measure them. But magnetic fields in a plasma environment of outer space, in the mantle of the Earth, they're locked into the Earth because of the iron, etc., nickel, etc., in the Earth's mantle and crust, where you have a permanent magnet. But the majority of magnetic fields in the universe are plasma magnetic fields, and they just don't exist without a source of energy. They would not be maintained for very long without a source of energy. They would be dispersed. And so anyway, the whole point is this is a long-winded approach to getting back to controlling weather. So I talked about Tesla tapping into the vertical electric field last week to power his Wardenclyffe Tower, and the problems he ran into with a guy named Westinghouse and J.P. Morgan, where their big plan was to sell electricity. So they could take the oil, or they could take coal, which they also controlled, And they could burn that and generate steam and then drive the turbines, which would then generate electricity, AC electricity using Tesla's technology. And that's what Westinghouse purchased in the early 1900s. Actually, it was the late 1800s when the deal went down between Tesla and Westinghouse. And I talked about that last week, how it kind of went sour when Westinghouse and the boys, the New York bankers, found out that Tesla had kind of, I don't know if it'd be swindling, but he wasn't 100% truthful, let's put it that way, in that Tesla knew he could get literally very inexpensive, I never use the word free, that's a misused word, but very inexpensive energy from the atmosphere and bypass the burning of coal and oil, and of course now natural gas. Natural gas, one of the biggest producers of electricity in the Western world anyway. They're still using a lot of coal in China, huge amounts of coal. They're trying to convert to natural gas, but China opens up a new power plant powered by coal every day of the week, of the year. China is opening up electrical power plants to feed their immense appetite for energy. Okay, so anyway, back to the idea of weather. What actually causes our weather? First of all, I'll tell you what would our weather be like if it were just the light of the sun hitting Earth. You would have a little bit of an eddy current at the terminator line. That's the line where the bright side of Earth meets the night side. So the daytime and the nighttime meet. That ring around the Earth is called the terminator line, not related to Arnold Schwarzenegger. The terminator line is simply where the bright, and of course the Earth is spinning, so that point is moving on the Earth. And that little bit of interaction between day and night would cause a little bit of an eddy current, but that would be it. That would be all. You would not have clouds, you wouldn't have lightning, you wouldn't have rain, you wouldn't have hurricanes or thunderstorms or tornadoes or wind or water spouts, I'm sorry. You wouldn't have any of these cyclonic storms. There are pictures of hurricanes on Mars. Now, the standard science story, let's talk about hurricanes for a second. The standard meteorological story for hurricanes is that they form from warm water. But we've seen hurricanes on Mars. There's no water, let alone warm water. The biggest hurricanes in history were formed in the North Atlantic in November. In November, in the frigid North Atlantic, the biggest hurricanes in history. So, no, just once again, silly science being pawned off on the public. And I'm going to be getting into Hurricane Helen here in a minute, if you can see where this is going, as potentially a manipulated storm. And what does a manipulated storm mean? That means it got a little bit of help. And how is that done? So I'll be talking about that. But first you have to understand what causes hurricanes in the first place, and how can you power a hurricane? Sounds impossible. How can you, anyway, I'll be talking about that in a minute. So, the weather would simply be non-existent if all we depended on was the light from the sun. So what causes the weather? How do these clouds form, etc.? And the Earth is discharging the solar capacitor, and it's like a comet. It's like this picture up here that you can see that's on this side, I'm sorry, discharging the solar capacitor. And this is the basically a diagram, an engineering diagram of the activity of a comet. It's discharging a solar capacitor. And I'm not going to go into all of this detail. It's in my books. And to, like I say, this show is a review. And to get further details, if you're a scientist or if you're an interested party, you have to go to my books, etc., and read them in their entirety to understand what's going on here. The first thing, let me just a caveat here, because every week I'd like to talk a little bit about science and how lame it is to standard science. The first thing that people would want to do, and this has been around for 50 years, this is not a secret or new, I'm just reviewing what's been around my work, and it's very well understood in Tier 1 levels of science and understood as being correct. But there's a tremendous amount of this, like I call it silly science because it doesn't make any sense, but it's promulgated by people with PhDs and degrees in meteorology, engineers, absolutely absurd science, like the idea that hurricanes form from warm water, and if there's a little more salt content, ooh, that makes it a bigger hurricane. Absolute absurdities. But the first thing that scientists or physicists would want to do is compare it to standard science. Then they'd say it doesn't match standard science, therefore it has to be wrong. That's their argument, that's their logic. But that just also shows they're extremely, extremely lazy scientists. I don't mention names, but you see them on the YouTube and you see them on radio shows. Scientists that are spouting the standard party line, very lazy people, because they got their degree and that's pretty much when they hung up their mental endeavors. They think they know it all, and what they learned was a bunch of garbage science, which anyway, but weather is one of the major areas where garbage science reigns supreme. So yeah, the idea that a hurricane forms from warm water is just absolutely absurd, that a big body of warm water can somehow automatically by itself organize into this storm violates the 3 laws of thermodynamics. It can't happen. Left to itself, a hurricane would simply dissipate in all directions. So there's something powering it, some serious form of energy, and that's the vertical electric field. So to give you an idea, let's just take a cloud. Let's take a cloud. How does a cloud form? The cloud actually forms because of the vertical electric field. If you did not have the vertical electric field, there would not be any clouds. And it's the same situation works whenever you have an electric field that's across a fluid body like an atmosphere, or a plasma in outer space. The same situation occurs. Here's how it works. There's particulate matter in the case of a cloud. It's the water, small pieces of dust or water droplets, and they discharge the solar capacitor, and in doing so, it causes them to charge slightly negatively because of it comes down to the fact that the electrons have much more mobility. Their charge to mass ratio is extremely high compared to everything else. Ions, protons, whatever, 2,000 times more than a proton. Hundreds of thousands, if not millions of times more mobility than an ion. So if you have a discharge in any type of plasma or free-flowing atmosphere, etc., the majority charge carriers are electrons. And guess what? They are negatively charged. And so imagine, this is an example that you can imagine, average person. Let's take a rock in a stream, just a water stream. You go out in the country, beautiful stream, there's a rock there in the stream. What happens on the upstream side of that rock? Well, there's pressure, and the water is hitting that rock and it builds up pressure, and then the water has to get around the rock, and so what happens, you have a little eddy current on the lower side of the rock, and so there's a lower pressure, but that water then comes back together and keeps flowing down the stream. That's the same thing that happens with this over here. You can see it in the diagram. And so the same thing happens in an electrical discharge. So I just explained why the electrons form the majority charge carrier in an electrical current, and so when they hit something, they do the same thing. They form a pressure on the upside, which causes an accumulation that causes that region to become negatively charged. And then the ions, because that's maintained because of this electrical discharge, that's what this, at the very top, it says the plasma discharge comet model, that's what causes clouds. And so the water droplets start to accumulate and form a cloud. This would not happen. People in meteorology can't tell you why clouds form. They can't tell you why they go up into a cloud and there's no electric field inside the cloud, because the cloud is a conductor and it's constantly working to distribute that charge around the edge of the cloud, because it's a conductor. And so these processes are continually at work. But I just explained why raindrops form, and if it's cold enough, guess what? Crystals form, and we call that snow. But they're not any crystal, they're six-sided, very symmetrical crystals. And the reason those form is because there's an electric field, and you can duplicate this in a laboratory. This is not made up. This is people, for a long time, I talked about this before, were trying to make snowflakes in the laboratory. And they couldn't do it. They put a pin in there simulating the little dust particle that's the formation, the center formation of every snowflake. And they couldn't do it. And so when they put an electric field on that pin, all of a sudden snowflakes formed, six-sided snowflakes. And they started growing them and classifying them, etc. And that's duplicating what happens in nature. But where does the electric field come in? Where does it come from? In nature. It's from the vertical electric field. So what I'm explaining to you is that you would not have clouds. Therefore, you would not have lightning. And the lightning, this is another silly science from standard meteorology, that somehow the energy of lightning, the electrical energy, forms inside the cloud and then comes shooting out. Well, you know, it's kind of believable when I was in 5th grade, but let me tell you, as a physicist, it doesn't make any sense at all, because if you have some battery that's forming, then the least resistance discharge of that battery would be internal. So the discharges would never ever get outside the cloud, if that was the formation of electric charge in a cloud. But it's not. The electric field and the electric discharge that happens with the cloud is just an intermediary. It's the discharge from the ionosphere to ground, and the cloud just happens to be in the middle and helping reduce the dielectric that's in the atmosphere, so that's where the electrical discharges happen. So wasn't it amazing, 10, 20 years ago, when people started discovering lightning above the clouds? And all the way up to X-rays. They've even observed cosmic rays coming from above clouds, high energy electrical discharges above the clouds. So the cloud doesn't generate electricity and shoot it out towards the ground. Silly science. Absolutely absurd. But this is what standard meteorology would tell you. Where does the energy come from? And then the idea they're trying to pawn off on you is that the sunlight comes in, stirs up the cloud, and then the clouds move against each other, and then they move against each other and then cause a tornado. Absolutely absurd. Absolutely absurd. Okay, so getting back, now that you know what causes the clouds, now what happens, how do hurricanes form? Okay, so the end result is that the clouds that are forming over Africa, primarily, we're talking about Atlantic hurricanes. The clouds form over Africa during the rainy season. You get the discharge of the vertical electric field through the clouds. They hit the ground, and so you have lightning all across the equatorial region of Africa. They when those clouds then, they're already forming a nice electrical current from the ionosphere down to ground, because ground is ground, and that's accepting the discharges from it's a capacitor. But what happens when that cloud rolls out over the ocean, over the Atlantic Ocean? There's a little kind of a nub there on Western Africa, and these hurricane clouds that eventually form hurricanes come rolling out over the ocean. So what happens? Well, all of a sudden you don't have your nice ground there anymore to take those electrical discharges, and the water is a very poor conductor relative to ground. And so what happens, it starts to ionize the air at the surface of the ocean, and the air ionizes and it starts to form a vertical current going upwards. Well, what happens when you have a rush of fluid in our atmosphere? It's called the Coriolis force. It starts to spin. It's like when the water goes down the drain. When the water goes down the drain, you get that spinning, that vortex motion. So it's the same thing, but going up instead of down. And so when it moves up, the ions in the electric current, it forms a rotational pattern. That's what powers the hurricane. I've talked about it on this show before. Go to some of the earlier shows when I'm explaining this in detail also. And the reason the hurricanes move westerly is because it's an I cross B, the electric current versus the B field, which is Earth's magnetic field, and that causes it to move westerly. It's the force. It's explained by the current crossed with the B field, and that's the end resulting force. Okay, so anyway, now how do you control a hurricane? Well, if you can induce or augment the current that's currently powering that hurricane, then you can increase the energy in the hurricane. So here's how they do it, is with a laser satellite. You take a laser satellite, and these started to launch around the year 2000. The reason I know about this is because in the 1990s, I was working with Russian scientists, and we discovered the true cause of hurricanes, and this information was actually given to the U.S. military to develop the technology to drag hurricanes offshore and away from landfall, and to prevent all of the damage that happens with hurricanes. Instead, the U.S. military took it and developed it as a weapon, where they could form hurricanes, they could form tornadoes using laser satellites. So the big laser satellites started to launch around the year 2000. And so you could see many of the, there was a Hurricane Francis, I forget what year it was, but it was, it went in the Atlantic Ocean, and they were testing, and they could drag it up and around it. They could make it go in circles in the Atlantic Ocean. Hurricane Katrina was a manipulated storm. Hurricane Helen has all the earmarkings of a controlled manipulated storm, because it didn't decrease in energy when it made landfall. That's when they short out. It's the opposite process of the formation of the hurricane with the clouds coming across Africa. It's the reverse. When it hits land, then the hurricane energy is dissipated because the electrical current is shorting out to land, and the hurricane dissipates. But in the process, you have a lot of tornadoes on the leading side of that hurricane as the discharges start to occur as that hurricane makes landfall. And so those tornadoes are some of the biggest, cause some of the biggest damage. And of course, dumping the rain that has accumulated in the hurricane once that comes into shore. So the idea that literally the Russian scientists, along with myself, gave this technology to the U.S. military to develop so that they would prevent hurricanes from damaging land, prevent hurricanes. The U.S. military took the technology, developed it into a weapon, and is actually using it against our own population. So the insanity in the world, it just never ends. The same scientists from Russia went to the UN. This was in the early 2000s, and told them the United States has these military weapons. They're weaponizing the weather. And we knew at that point, too, that they would be able to control weather itself, low pressure cells, and eventually control long-term weather, which we call climate. Okay, so at any rate, I wanted to get this in, and now I've explained this so that anybody out there can understand it. Now, this is also why they keep putting out the false information about hurricanes being formed by warm water. Because as absurd as it is, it doesn't make any sense in terms of physics, but they keep pawning that off on the public to hide the idea of what they are doing here relative to the hurricane manipulation. So I'm not going to go into the politics of why this is being done, but I'm just my role here is to explain the science, and you can pretty well make up your own conclusions from what I'm telling you. Okay. Well, that is. I want to change subjects now. I spent a little more time on this than I wanted to, but I had to explain it so it's very clear. So the naysayers, by the way, just talk to them, the clowns out there, that I call them clowns because they are lazy scientists who defend the standard science world. I'm explaining this so the public can understand it and not have to depend on you guarding the realm, the holy realm of standard science. So that's what this show is all about, is explaining so the public understands. Okay, and then also showing how silly and ridiculous standard science is. When you see the weatherman talking about, or you see the hurricane prediction centers making their predictions for hurricanes for this upcoming hurricane season, absolutely ludicrous. All of the different factors, the high wind shear and the El Nino or La Nina. I can't believe these people. They get paid. These people get paid to pawn off garbage science to you. And there's a lot of that. Anyway, okay, so now I want to jump off to a guy who really was an amazing scientist. And I want to first start off by dispelling this rumor that Albert Einstein was an atheist. And that label is given to people like Stephen Hawking, because scientists want to promote that the very best scientists were atheists, and it's not true. Because they did not belong to organized religions. They say that if they did not belong to an organized religion, then they're atheists. But both Einstein and Stephen Hawking and quite a few other very famous scientists believed in the organization of the universe. And in Stephen Hawking's last book, last one he actually wrote himself, he talks about that, the very last paragraph of the book. He actually talks about that and says that if he could just discover one other aspect of this amazing universe, it would be, in terms of physics, it would be, to him, one of the pinnacles of success. In the same way with Einstein. So they're not atheists. They believed in a very high order of organization in the universe, and that's why they studied physics. That the physics on this side of the universe is the same as the other side of the universe, and therefore it's a very it tells you that there is an organization in the universe that indicates a grand design, which indicates a grand designer. Okay, so now talking about some of the discoveries of Albert Einstein. First of all, just a little bit on his history. He was born in 1879. Now, he's commensurate with Nikola Tesla. They were both born in the 1800s, developed their career in the 1800s. Einstein was getting his PhD just as the turn of the century occurred, and Nikola Tesla was already in the United States doing his work. In fact, there's a funny quote. They asked Albert Einstein what it feels like to be the greatest scientist in the world, and his response was, go ask Nikola Tesla. And one of the questions is, did those two ever meet? Because they were on the East Coast. Tesla was in New York, and Einstein was in New Jersey. So did they ever meet? And the best that anybody can reasonably conclude is that no, they never really met. They knew about each other, but they never really met. Okay, so one of Einstein's major discoveries was dealing with Avogadro's number. This is the number of atoms in a mole of material. And so anyway, if you don't understand that, don't worry about it. But anyway, it was a major contribution to understanding the size and dimensions and weight of atoms. In other words, you take a fixed quantity of something, and it has a certain amount of weight to it, and then how many atoms or molecules or whatever would be in that quantity of material. And so the idea Avogadro's number was due to another person, but an Italian, last name was Avogadro. But Einstein kind of put the frosting on the cake in giving a method for calculating. He won the Nobel Prize for what is known as the photoelectric effect. Now, it's an experiment. In a lot of these cases, the experiments came along and people did not understand the results. And Einstein gave the interpretation. So Einstein gave the interpretation that light acts as both waves, which was previously understood very well going back to Newton. Newton had divided light into its components using a prism, so he understood that concept and the wave nature of light, etc. But Einstein is the one that in a lot of these cases, I call it turning the key. You put the key in the lock and you turn it. And these are maybe small, might appear to be small discoveries, but they're major things that came along, and people really didn't have a concept that there was this dual nature of light, that if you did certain experiments, they would act like particles, and if you did other experiments, they would act like waves. But they never acted like waves and particles at the same time. So it's kind of like nonsensical. Okay, then also which this is a very rare thing about Einstein, is that he got the Nobel Prize for the photoelectric effect, but his biggest discoveries were special and general relativity, which dwarf the photoelectric effect. But anyway, I'll be talking about some of these other effects. One of his discoveries was dealing with something called Brownian motion. In other words, you take a liquid, you drop some particles in there, small particles, and they seem to move around. They just keep moving around. And there's really no reason for that. It's very similar if you look at, say, the light beam is coming into your house and you're in the window, and all of a sudden all this dust is floating around, and it's like moving around like this. Very similar type of activity in terms of physics. And the question is, well, back in the 1800s, they were like, well, what's causing this? What's causing these particles to move around like in random directions and with random motions? And it turns out it's related to the movement of atoms and randomness in the fluid, whatever it is, water or air or whatever. And Einstein figured this out. So it's there again, another discovery. There are people that criticize Einstein and it's really pathetic. And I will go into some of this because you may hear about this. Did Einstein copy everything he did from somebody else? No, no. When you see somebody that had that level of work, or the work, the mathematical work that went into general relativity is enormous. He worked with very high-level physicists, solving some of the biggest riddles of the time. Now, special relativity, the Michelson and Morley experiment came along and had it was designed to calculate or measure our movement relative to the universe. And thinking that certainly we're in orbit around the sun is in orbit around something else, and everything is moving. But there must be some kind of basis for the universe. And the Michelson-Morley experiment was an experiment with light, and no matter what direction you look in, the speed of light was the same. And so there was something called the Lorentz transformation, which had already existed. But Einstein is the one that came along and made sense out of it, turned the key again, and realized that light travels at the same velocity relative to the observer, something that does not make any sense at all. But it explains observation. And so, I mean, and that was, there again, all of the greatest physicists of the time were working around this, and Einstein was the one that figured it out. He turned the key and made it understandable for everybody. General relativity was a big leap on top of special relativity, but I'll talk about some of the problems that that general relativity have. In that, and I've talked about this before, the principle of equivalence. That's what I want to get to tonight. Is there was a statement, and this is kind of what kicked off this thought, a good topic for a show. There was a scientist, and he's a rather younger scientist. He's on the internet a lot, and he's got a British accent. You might know who I'm talking about. And like I say, I never mention names here. I don't want to criticize people, but the basic statement was that with general relativity, you cannot understand your reference relative to the universe. And there's a caveat to that I want to include here, because it's not really true. The idea of the principle of equivalence is as follows. Say you're in an elevator and you're out in the middle of nowhere, there's nothing around you, there's nothing in the universe except you and your elevator, and you do some experiments. In fact, one of the experiments is you shine a light beam from one wall across to the other wall. That's all it is. Okay, and it'll go straight across the elevator and hit exactly on the opposite side of the elevator. But if you accelerate that elevator at, say, the same gravitational acceleration as the sun or Earth or some other massive body, then that light beam won't go straight across anymore. It'll bend down in a parabola, and it will. You can simulate this dual situation in an elevator or in the gravitational field of a massive body. The problem is, since you can't get these massive bodies in your laboratory, it's never been proven. So there were ways to check this out, and one of them was with the Arthur Eddington experiment, which is literally was a botched job, where Eddington cherry-picked the data, literally, and then I'll just be honest with you, he falsified the data, and that's never really been reproduced since. But I want to give some examples tonight of the caveats to general relativity. Here is how it works. Say you're sitting in your chair, and you're out in the middle of nowhere. There's no planet around you. There's no sun. You're in the middle of of an empty universe, just sitting in your chair. Okay? Take a stick and put a ball at the end of the stick. Okay, here, let me see. Okay, get these in the camera. So you got two balls and a stick. That's all it is. And now this could be a stick that's many, many miles long, or it could be really long. But just for our example here, you're sitting in your chair, you take the stick with the two balls on it and you hold it vertically, one ball above the other. If you're sitting out in your chair in the middle of the universe, now I'm going to use my pen as an example. So we're sitting out in a chair in the middle of the nowhere, there's nothing around, and there's a ball at the top of the pen and another ball down here. Okay, now you accelerate in the vertical direction, and you measure the force on the balls. You have, for example, a scale that you measure the forces. Now you compare that, go and sit on, let's say, planet Earth, like I'm sitting in a chair here on planet Earth. Use the same pen, and according to Einstein's relativity, you should not be able to tell any difference. But it's not correct. There is a difference. And in a gravitational field, what happens is, since the top ball is farther away from the center of the Earth than the bottom ball, it is pulled with slightly less gravitational pull than the bottom ball that's closer to the Earth. So you could measure a difference. And you say they put you in a chair in Earth and in a chair in this elevator that was accelerating with the same 9.98 meters per second squared acceleration as the gravity on planet Earth. You could tell a difference simply by making a measurement on the top ball. There would actually be a force between these balls pulling them apart. You could measure that theoretically. Okay, now if your stick was really long, you could really, there would be quite a bit of difference. You would measure quite a bit of difference. Now, most things in the universe are not just sitting still in terms of planets or stars or galaxies. Everything is spinning. So now what happens when it spins? Okay, so now your ball has a totally different dynamics. We're starting to deal with rotational dynamics. And since this ball is farther away from the center of the Earth and it's got the same velocity, what's going to happen is that actually the top ball has more velocity than the bottom ball because it's turning around the Earth. And so what it's going to try and do is go off in this direction into a different orbit. Literally is what's going on. So you'd be able to tell that. So you would be able to tell that you are actually spinning by doing the same experiment. And even though you have the same physical force equivalent, it's not equivalent, because you can actually make these measurements. There's a good example. There's a pendulum that if you set up a very, very, very long pendulum and let it swing back and forth, what's going to happen? Well, the Earth is going to rotate underneath that, and over the course of 24 hours, if you're standing there at the pendulum seems to be swinging around. But it's not the pendulum. The pendulum keeps going straight, keeps going back and forth and back and forth. It's the Earth turning around underneath the pendulum. And so that's another way. Another way is measuring the tides. Every day we have the tides. Okay, also tornadoes, hurricanes spin, and it's that Coriolis force. So you can measure the Coriolis force of Earth in many different ways. Now, the Earth is in orbit around the Sun. So the Earth is spinning on its axis. You can measure that with this experiment and tell the difference between some guy out in an elevator out in the middle of nowhere, far away from any masses, and accelerating at near the speed of, at the same acceleration rate as the person on a mass planet, a planet or a star or whatever with mass in it. Now we're orbiting the Sun. Okay, so if you take your stick once again, like this, and we're orbiting the Sun. Well, first of all, we're spinning on planet Earth. Now we're orbiting the Sun. Technically, with your two balls and a stick between them, you could measure the fact that we are orbiting a star. and you could see where that star is. You could see about how far away it is and how massive it is, etc. And so now the sun is orbiting the galaxy, the galactic nucleus. And really, there's a misnomer also that all the stars are somehow orbiting this massive black hole in the center of the galaxy. Not true. The star, for example, we're quite a ways out in the solar system, we're quite a ways out in the galaxy, out towards in the boondocks, you might say, far away from the center of the galaxy. And we are being attracted towards all of that matter that's inside of our circle, the circle of our orbit around the galactic nucleus. All of that matter accumulates as if it were near the center of the galaxy. So we're actually orbiting all of the matter in the galaxy. Okay, so once again, your stick with the two balls separated at the end of this stick could detect that if it were sensitive enough. Now we're going to go back and pick apart general relativity just a little bit more, because what it says is that in your experiment, going back to that original experiment where the light comes through and goes across, if you're in your elevator out in the middle of nowhere and you're accelerating, then the light beam should go like this. So the principle of equivalence says that if you're on a massive star like the sun and you shine a light beam by, that should curve. And it actually turns out not to be true. What's causing the curvature of the light beam around the star is an electric force. It's called the induced electric dipole force. It's something I discovered. And interestingly enough, you can put it in a laboratory. You can put this in a laboratory and actually measure it. And there's very simple experiments. I talk about this in my book as having done this in front of classrooms. And so basically what you do is you take a Tesla coil with basically a pinhead with a very high alternating voltage, and you shine a laser beam across the top, and what it does is it stretches down the beam. So if the Tesla coil is turned off, the beam goes straight across. If the tip of the Tesla coil, as soon as you turn the Tesla coil on, it stretches down the beam. And that's because the induced electric dipole force is always attractive. Okay, so that's a complicated topic. But the end result is that general relativity has some problems. Now, the idea that we are in this curved space-time continuum works if you're a point source. If you're bigger than that, it doesn't work anymore. Because of your extent, you notice that as you move through that gravitational field, the force on, say, your head would be different than the force on your feet. Just like the force would be different on one ball as opposed to the other ball if they're separated by a stick. You could actually put a little scale in there and measure that and determine the amount of acceleration because it's different. And so general relativity works great if you're a point source. It doesn't work if you're not a point source, and since everything in the universe is not a point source, then general relativity has some issues. And so anyway, the end result is that because of this principle of equivalence being wrong and not testable in a laboratory, and the fact that the original experiment, the Eddington experiment, is literally wrong and faked, there's a huge block of science that has to be rethought. But there are good parts of general relativity if you're a point source. So at any rate, I hope this makes sense to you out there. But I just wanted to get back. I was talking about hurricanes before, and I wanted to wrap up a thought. In the early 2000s, the Russian scientists that I had been working with on the issue of guiding hurricanes away from populated areas went to the United Nations and said that the United States military had these weapons of weather control, weather modification, and wanted a treaty. So the United Nations drew up a treaty, and the United States would not sign it because one of the stipulations was that it could not use it against its own civilian population. And that is what's been going on since the early 2000s with weather manipulation, weather control, other forms of weather modification, but the main form of weather modification has been accomplished using laser satellites. Okay, so anyway, I wanted to get that in so that's very clear, because there's a lot of noise on the internet about this, and I wanted to make sure you fully understand what's going on.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.